Well, welcome everybody. This is William McKnight, and you have arrived at Autonomous Analytics in the Real World, giving your data a voice, best practices at Foursquare and beyond. We have I think, a great presentation for you today, a great learning opportunity about artificial intelligence and its role in analytics and what the marketplace has to offer now in terms of artificial intelligence. A lot of the things that we're doing is not dissimilar to what we were doing before, but we have so much more intelligence, so much more efficiency now to bring to the table in terms of these things. It's really going to become a competitive differentiator, and we want you to know about it here. So, all right, just trying to advance the slide here. I want to show you everybody that's going to be talking today. Here we go. All right, so I'm going to kick it off. I'm going to be talking about preparing your environment for artificial intelligence. Again, William McKnight here, president of McKnight Consulting Group and senior analyst with enterprise data at GigaOM. And I'm going to be followed up by a fascinating presentation you won't want to miss. Comes from Foursquare. And we have Sam Grossberg, the engineering director there, as well as Victor M., the senior analyst and consumer product lead at Foursquare. And they're going to be talking about their implementation of Anodot, which is, you'll learn about that, but that's their implementation of artificial intelligence looking at their anomalies. And I'm not going to steal any of their thunder, but I do want to tell you up front that they have 200,000 metrics that they are monitoring through Anodot. That's an amazing amount to me, but it shows you the possibilities. And if we do nothing more, we want to open up the possibilities thinking for you out there and show you all the possibilities of things you can be monitoring. And Anodot is going to be represented by Ira Cohen. He is their chief data scientist, and he will come on after Victor and tell you a little bit about Anodot. That's the technology that Foursquare has implemented. And we'll have some Q&A at the end, so please do be logging your questions along the way. Okay, so I'm going to launch in here to my kickoff here, preparing the environment for artificial intelligence. Now, like I said, a lot of the things that we're concerned about aren't dissimilar to what we were concerned about 5-10 years ago. We are gathering information from our business intelligence, from our analytics system. Maybe questions like this: our comps are up. I wonder if our customers are happy. Things like this: our sales are down. Should I worry? Or how about this one? Our sales are up, but there's no money in the bank. So what is going on? Sometimes when you can triangulate multiple data sources and bring intelligence to bear on that, you can find the answers to these seemingly insurmountable questions with artificial intelligence. So you need a commitment to data and to intelligence. And really, I think my role here is to talk about the data part of artificial intelligence. It's very important. Getting your data act together and then sharing that with artificial intelligence. Every business will struggle with the task of identifying meaning and generating action without this commitment. So by no means do we have something that is super easy, plug and play, no problem. You do need to work on your end in governance, at data, and the things that are surrounding that. Spreadsheets are not the answer, though. You will never get ahead with spreadsheets or with any sort of maturity 1 level commitment to your data. And I think we all kind of are starting to understand what that means to not have a mature data environment. This is very important. And I view artificial intelligence as being on the spectrum of data maturity, obviously at the high end, but it's something that we're aspiring to. And it's something that if you accept it as something that is here to stay, as I do, as many do, it's going to be a competitive differentiator. So the use of artificial intelligence, a lot of companies are already doing it, such as Foursquare, for example. And we're going to share with you some of their story, as well as some other stories about companies that are using artificial intelligence today to get to the bottom of things.
Hey everyone, I'm Sam from Foursquare. I'm the Senior Director of Engineering for our developer platform. And I'm here today to talk about how we use Anodot to help us with anomaly detection across a huge number of metrics that we want to track for the performance of our products. Okay, so I'm going to start out by discussing the history of Foursquare and how the products that I'm responsible for developed and how we used Anodot in particular to address some of these challenges. Foursquare was founded in 2009, and our initial product was a check-in app. We pioneered the checking into a place, sharing it with your friends, leaving tips for other people who visit. And from day one, our founder, Dennis Crowley, really envisioned being a sort of location technology platform. And so in 2009, we launched our first API. That's a publicly available application programming interface for using Foursquare location technology to power other products. Over time, we collected over 13 billion check-ins, people saying, I'm in a place, whether it's a fancy restaurant, an In-N-Out burger, a gas station. People love to check in, share where they are in the real world, and do sort of a life log of all the places they visited. And we've used that technology, we've used that data to build incredible technology using all the check-ins as training data to power our own artificial intelligence to understand where phones are moving in the real world. We created a product in 2013 within our apps called Pilgrim, which was an internal code name for the product that has stuck. And we continue to use this technology today to track where phones are going in the real world, empowering features like our notifications when you arrive at a restaurant will tell you what the best item on the menu is so you can order that. In 2014, we started expanding with partnerships with some of the largest tech companies in the world. We now power Microsoft, Twitter, Uber, Snapchat. We power location-based features in many, many different products. And we've continued building a platform and technology and a location panel, one of the largest commercial panels of foot traffic in the world. And over time, have allowed other developers to use that through one of our products, the Pilgrim SDK. In this time, we've collected an enormous amount of user-generated content. We have 105 million places of interest around the world that are maintained by 43,000 super users, Wikipedia-style editors who maintain the freshness of our database and help us create the most effective database of places of interest in the world. We also have 125,000 developers using our developer platform. Some of the biggest customers use 3 different products. We have a database product that allows Apple Maps to show Foursquare locations around the world. So if you search for a restaurant, you may see Foursquare venues in our results. We have an API that allows Twitter, when you tag a location in a tweet, Twitter uses the Foursquare API to find the locations that you might be at. And most recently, we've developed a product called the Pilgrim SDK, which powers apps like TouchTunes. TouchTunes is a jukebox app that powers bars all over the US and Canada. They have physical jukeboxes that allow people to play music, and a mobile app that goes along with it that allows you to buy and play songs directly from your mobile phone. TouchTunes uses this to send you notifications when you arrive at a bar, sending you suggestions about what songs to play, and have found this to be an incredibly effective way to engage with their users based on the location context in the real world. And more recently, we've helped Tinder launch their Places feature, which has allowed them to create better matches for people who are dating based on the places they visit in the real world. So if you go to the same coffee shop, you might be more likely to be a match. This product is powering some of the largest companies in the world's location, and it's incredibly paramount that we have a really high degree of reliability, ease of use, and precision for our technology. This is critical for our success with our customers. And so we want to be using the best tools available to us to ensure that we have extremely high reliability and accuracy. And that's where the challenges came in that Anodot has helped us solve. I'm going to turn it over to our product analyst, Victor, who is deeply involved in the integration with Anodot and dealing with some of the challenges that Anodot's helped us with.
Thanks, Sam. Really appreciate it. So overall, my name is Victor M. I am a consumer product analyst working on both of the first-party apps, Foursquare City Guide and Swarm. Prior to that, I was a member of the analytics team, and I was helping Foursquare find its product market fit on the enterprise side, and also help Sam G specifically set up alerts and metrics for the Pilgrim SDK team. Overall, turning back to like early 2017, we knew that we had a handful of challenges ahead of us. First was being able to scale our monitoring. To this day, we have over 30 partners that are using the Pilgrim SDK, which includes apps like Sam mentioned, Tinder, TouchTunes, Capital One, amongst many others. We also knew it was impossible to track every single metric for each partner with our current workflow and our size of our team. In addition to this, we needed to expedite to real-time alerting. The process of having a human detect what is wrong was not fast enough, and we could not let any critical issues arise go unnoticed. And lastly, we need to be able to communicate effectively with both our internal and external stakeholders. And we knew that with our current existing tools, we would have challenges meeting all of these expectations. So overall, this is actually an example of one of our existing alerting tools. This is an alerting tool that ingests metrics, and anyone in the company can actually set these alerts. Alerts would be triggered when a threshold is passed, and as you can see over here, if it passes the green line, we would warn somebody, and if it passes the critical line, this would be actually set to the production team primary on-call. And the biggest challenge with this is that most of these thresholds required manual input of users who are knowledgeable about the cadence and behavior of these metrics. And when scaling upwards and introducing new clients, we couldn't really get ahead of that. We wouldn't be able to learn every single partner and their behavior. And we would also be at the mercy of a variety of different extraneous factors that can trigger this alert. This includes artificial factors such as deployments and version changes. And this also includes natural factors such as seasonality from holidays. And, it's actually really funny, but irregular weather patterns. So with this in mind, we knew that for both of these internal and external factors, we can't truly account for all of them. And sometimes changes that occur across teams would affect other teams downstream. For example, when the Pilgrim team deploys a new model for stop detection, this can lead to unexpected behavior for our consumer apps, such as improving the precision for our model can actually account for how it changes retention or how it changes engagement within our first-party apps. And we knew for sure we didn't want to affect our partners in a negative way. So overall, I do want to also show you how we monitor dashboards in the past. This is actually a chart of a check-in reminder ping, which is the notification we provide for our Swarm app when somebody enters a venue, and we would tell them, hey, don't forget to check in. The whole value proposition behind this is that this ping is to give people into the habit of checking into a place, and for us, it's to improve our location detection model. It was like our positive feedback loop. But in addition to this, it was to remind people and to give people more context on the venue that they're checking into, and to remember fun facts. In fact, one of my friends actually reminded me that I was like, wow, thanks for Foursquare for telling me that I've been on a 5-day streak at bars. And then there would be other moments where somebody would tell me, yeah, I've been to the gym for 5 days, and Swarm was able to tell me that. So jokes aside, going back to the chart, this is actually a time series considering 3 series of lines, one that represents 5-minute increments of this check-in reminder ping for today, yesterday, and 7 days ago. And this allows us to give us more of an assessment on changes in behavior for day-over-day or a week-over-week basis. But with that in mind, with having these green, yellow, and blue lines, I have a quiz for everyone, and I was wondering if anybody here can detect the anomaly. And I just realized that everyone's muted, so I'm just going to tell you the answer. We see a decline in around 611, and unless you're squinting, you can't even see. You can see that like today's behavior for the check-in reminder ping is down compared to yesterday, as well as compared to 7 days ago. But for those reasons, this could be due to a variety of factors that I listed above, such as seasonality and changes in behavior. And furthermore, it was actually very difficult to connect and correlate anomalies that we see with other metrics. Most of the time is spent on my end or on the product management end or engineering end to address these issues and investigate. And the sad thing is, most of these issues go unnoticed. So we don't have enough eyeballs to look at every single chart. And for sure, we couldn't do that for the Pilgrim SDK. And after that, most of these alerts are usually lumped into a group and sent as an email. This is actually an alert that we received for our week-over-week passive check-ins. And it was signaling that, hey, week-over-week USP check-ins are down over the past 2 hours. The truth of this alert is basically, this was triggered because of the holiday. And we knew that behavior would be down due to the fact. But with the influx of alerts, sometimes teams would actually even often get desensitized by the inundation of them. And I know for sure I did, because those were too many alerts to handle. So in summary, overall, our existing alerting solutions had frequent false positives and false negatives. They were not always actionable. They were difficult to correlate and connect issues, and they were very time sensitive to investigate. So overall, this is one of the challenges that we had was we always had this argument of whether or not it was worth for us to use more engineering and product resources to build a solution in-house and really just like bumping up our alerting. And we knew that Anodot was a product that focused on real-time analytics and automated anomaly detection to detect and determine outliers through time series data. Overall, out of the box, Anodot was able to ingest and measure over 200,000 metrics from our consumer apps and our partners. And this is a key example of one of our partners launched their developer key instead of production key. And the anomalies that we caught for rate limiting was that their traffic would go to 0 every hour. So you would see spikes like this. As a result, what we were able to do immediately when we saw this alert was communicate with our partners and investigate on what's going on. We were even able to identify that we were also identifying some like really quick wins, such as being able to determine just regular cadence when a new partner is launched. So what you see over here, the yellow line actually represents when a partner has just ingested the SDK, Pilgrim Engine status would be installed, which basically means that people are using the Pilgrim SDK on their app. And as a result, we saw a spike in users using the app. Eventually, what Anodot was able to do was to learn this behavior, and we would tighten the cadence in how we saw any irregularities with the launch. Moving forward, this also gave us the ability to communicate effectively regarding the launch on Slack using the Anodot webhook. We were able to check for any of the other correlated metrics and address any issues as they arise, stepping into them if they were urgent. The next thing we're also able to do is actually what you're seeing here is a view of the Anodot maps on Anodot. If an alert is stepped on, we're able to see if there were any other anomalies that occurred at the same time. And what this chart you're seeing over here shows 2 apps, specifically Swarm iOS and Foursquare Android, and they were affected by a similar server-side outage that lasted for around 20 minutes. We were able to correlate these metrics with other metrics, which traditionally, when operating, we weren't able to, like, each of the consumer products would actually have their own separate dashboards, and we would have not monitored this, and this would be monitored by a different set of teams. So overall, this was able to give us the ability to like correlate and connect cross-functionally, and that we haven't been able to do so before. Moving to the next slide. Seems like there's a lag. Moving to the next slide, we were also able to segment critical alerts from non-critical alerts. The example you see here is actually a queue worker webhook, and if the queue size gets too big, the service for our Pilgrim SDK is backed up, and we would have to address it with our engineering and product teams. This is something we knew from a top-down level as a critical alert, and we were able to attend to it, start an investigation within less than 10 minutes of time without having to sift through a flurry of those huge emails that you saw earlier. So I think this was actually a really great win for us. And again, we would not have been able to do any of all this with our past alerting tools. So overall, this has allowed us to invest more into scaling our usage of the Pilgrim SDK and have our product managers, analysts, and engineers focus on what matters more. And I think that's really building the features for the Pilgrim SDK, allowing apps to be more contextually aware and to really understand like how we all interact in the world. Because I believe like one of the things about Foursquare is just we don't want to just become the only player in the check-in ability. We're trying to give and empower other applications and other developers the ability to like check into a place, understand where their app is, and truly like, you know, have a more just like better consumer interaction with their apps. And as next steps, we're teaching others in the company how to use Anodot. We're already integrating this with the consumer product team, and we hope to proliferate this further to other teams to use this. And that leads us to adding more metrics, more than the 200,000 that we've had so far. So overall, we believe that this could help reduce investigations and overhead by other teams. And we're also integrating Anodot's anomaly detection tool to workflow and processes, such as adding pager duty and assigning critical alerts as a ticket to make it a seamless process when investigating. That's all I have for today. Thank you so much for listening. And I'll pass it off to Ira to close it off.
Very much. Yeah, this was a great presentation. This is Ira Cohen from Anodot. So what I'm going to discuss in the remaining time, and I'll leave some time for questions at the end, is give you a high-level view of, first of all, Anodot's vision for autonomous analytics, with anomaly detection being the first capability. And the second aspect is giving you a very brief highlights of how we built the anomaly detection system that we have in place that does all these the things that for Foursquare that you just seen. And if you have further questions and want more details about the algorithms, you can always shoot me an email or go to our website. We have a lot of case studies and white papers there, so you can download them. All right, so let's move along. So a little bit about Anodot. We were founded in 2014 plus 4 days. Actually, June 15th was our first day of operations. Since then, we built a SaaS platform that collects time series data, time series metrics, and does analysis of these time series metrics. Today, we have around 240 million metrics flowing into the system, 6 billion data points per day, various types of learning algorithms. And let's continue from here. Some of the customers, so you heard about Foursquare, and really what's interesting about the type of customers that are using Anodot, they're very data-driven companies that reached a point where they realize they cannot continue maintaining the business and the business growth in the same way without automating a lot of the processes, especially looking at the data. And as Victor mentioned, you can look at a few graphs and dashboards, but you can't really hire an army of people to look at all the graphs. And at 200,000 metrics, and some of them have millions of metrics. And I heard that Facebook mentioned that they measure 10 billion metrics, or perhaps even more today. It becomes impossible without some automation, without a system that looks at the data and automatically finds what's interesting in the data. So if we go to the next slide, just to give you a vision of where we're looking at, what we're trying to achieve. What is autonomous analytics, and what is it trying to achieve in the market of business operations, business analytics? If we look at it in the context of the four main pillars of business analytics: descriptive, diagnostic, predictive, and prescriptive, really BI tools do this today. But the work that you have to do is mainly manual. So to know what is happening, you have to look at dashboards and reports. To know why it happened, you have to manually do queries, manually correlate things, manually understand what causes what. And it takes time. As you heard, all this process takes time. You miss stuff, you get false positives, and when something happens, it takes a long time to investigate and understand why. Looking further, you want to know, what will happen. And today you have manual regressions, people are doing it in Excel and various other tools, and you're looking at very limited scope of data that can help you do the forecast. I mean, forecasting, for example, how many users will do a check-in in New York is not just related to how many users were there yesterday, but also relates to the weather today and to the taxis that are available and all sorts of things that you can measure. And if you use it, you can get a better forecast. The last point is being prescriptive. So you want to know how to, if you can forecast the future, you want to know how you can change it and what you can do to make it better for you. And today it's all done manually. So if, the vision of Anodot is to automate this process and using machine learning in all these aspects. So autonomous analytics for understanding what is happening, you use anomaly detection. For why it's happening, you use algorithms like correlation and clustering algorithms to help you determine and isolate the potential root causes. If you want to do predictive, you can use multivariate approaches using deep models like deep learning and other types of models, LSTMs and so on. And you want it all in real time. And then automated optimization algorithms can help you figure out, how can you make it happen, or if you can actually automate some of the actions, you can use tools like reinforcement learning to help you get to the optimal path to meet a target of your business. So let's talk a little bit more about anomaly detection and the root cause analysis, because this is what Foursquare is using us for today. So anomaly detection, as you heard, is a business imperative. I mean, anomalies happen, you don't know where they're going to happen, so you have to find anomalies in all your data, so you can find the unknown unknowns. You want it in real time. It's not useful if it comes very, very late, because then you're reacting to something that already happened and you might not be able to change, or you've already lost a lot. And you want granularity for all the data. You want to find anomalies at the highest granularity that makes sense from business perspective, because small anomalies can cause loss of opportunities or loss of money, and they tend to also kind of get bigger and bigger over time. And if you don't deal with them early, you might deal with a much larger issue later on. So if we go to the next slide, we can see that what are the main design considerations behind building an anomaly detection system. So accuracy and robustness. You've heard about false positives and how they desensitize people from looking at alerts, sometimes even real ones. So minimizing false positives is really critical for an anomaly detection system. And to do that, and to be accurate, you have to be robust to all types of signals. You have to be robust to constant changes in the environment in the business that is being monitored. So you can't be stale. You're not monitoring a closed system that never changes. You have to have a very scalable solution. So scales out to millions and billions of time series, not just in terms of collection of data. That's not that hard. Not trivial, but it's not that hard. But it's really the analysis of millions and billions of time series in real time with no configuration required by anybody, either analyst or data scientist. No configuration of algorithms, no configuration of thresholds, because that's not scalable when you're talking about millions and billions of time series. And that's the scale we're talking about here today, even today for a lot of companies, and the future for probably all companies. The last piece, you want to have algorithms that do fast root cause investigation that help you isolate and correlate all the anomalies so you can repair it. I mean, explain an issue or an opportunity and react to it as fast as possible. Otherwise, it's not helpful either. And that requires a bunch of different types of algorithms. So if we go to the next slide, we can see some of the the main approach that we have for doing anomaly detection. Basically, how do we do anomaly detection? We use 5 main components. Each one has its own special considerations. The first one is analysis for all the data, collection and analysis for all the data. That means that our algorithms, or many of them, have to run in memory on the stream of data itself before it ever hits any database. Otherwise, you lose the ability, you lose the scalability, you lose the real-timeness, and even you sometimes even lose the ability to adapt fast enough to changes. So we're talking about online algorithms, online meaning they live in memory, they update with every data point, and they detect anomalies in real time. Now, what are these algorithms? So the first set of algorithms are algorithms that learn the normal behavior for every time series. There are many considerations around that. For example, detecting whether there is or there isn't a seasonal pattern in the metric, correlating with events that are repeating events like holiday events or sales events, accounting for changes during normal times, during anomalies, so adapting for all these changes. And they have to account for different types of signals, and there are quite a wide variety of types of signals and distributions. When you start measuring from large systems, you see all types of behavior. There isn't a single algorithm that can capture everything well enough. So you have to have a host of different algorithms, and a selection algorithm that will be able to select the optimal ensemble of algorithms to find anomalies in every time series. So that's just the first step. The second, that's just learning the normal behavior. The third step is actually learning the anomalies themselves. And what do I mean by that? Not all anomalies are the same, and you can't treat them as the same. Otherwise, users will be flooded with anomalies that they wouldn't be able to rank. So you have to be able to rank and score and classify anomalies. And the reason we do this as a learning task and not as a static statistical task, saying, oh, if I'm far away from my normal model, then I must be very anomalous, is because we found out that that's not good enough. You have to actually, what people consider as a significant anomaly is very relative, depending on the level of anomalies that were there before. How surprising is this anomaly compared to past anomalies? And that's really the way people rank and score them, and that's something that can be learned. The fourth step is being able to correlate, and that helps with the root cause investigation. And correlation is not linear correlation. That doesn't work. You can try it, but it doesn't really work in almost any case. And in those cases, you actually need fairly complex clustering and soft clustering algorithms like latent Dirichlet allocation and other types of algorithms. But in order for them to scale, you have to modify these algorithms so they can run in reasonable amount of time and on millions of time series. And that means they cannot be more expensive. They're order n log n or break it up to a lot of n log n small problems. So that's the correlation part. The last part is really also important. You can get feedback from users. You can't assume you'll get feedback from users, but you can get feedback from users, and you can use it to help improve various aspects of the algorithm, how you detect anomalies. And feedbacks can be explicit or implicit, but using it is really critical. And it basically transforms the problem from an completely unsupervised problem to a semi-supervised problem, where you inject labels to the unsupervised algorithms that we have. So with this, I'm going to stop and so we have some time for questions. And if you have more interest to hear more about these algorithms, as I mentioned, we have some white papers, and we can also and some publications out there. And feel free to shoot me an email. Thank you.
Thank you, Ira. And we just have a couple minutes left, and we have a couple questions. So I'm going to fire away. The first one will be for Victor. Victor, how did you determine the metrics that you wanted to monitor?
Thanks for the question, William. So overall, I think that in determining the metrics, we knew exactly what were the key things that we cared about just based on a high level side. So I actually just sat down with Sam Grossberg and really just asked about like exactly what could go wrong with the Pilgrim SDK, and like let's just think about it from that lens. Overall, we like led to two specific type of metrics that we care about. One was Pilgrim engine status, which you saw earlier, which was this idea of understanding the heartbeat of the Pilgrim SDK. If people are using it, we were able to know exactly if people have enabled SDK or if they disabled it. If we've seen a huge surge of disables, that would be classified as a critical alert. The other alert that we cared about was also just understanding our Pilgrim SDK service. So if there was like a server-side outage, we would have to respond immediately. And then lastly, I think some other extraneous alerts that we cared about was just overall visit behavior, because we knew that the visit behavior for different apps that are using the Pilgrim SDK were going to be different. They were going to be idiosyncratic because of the variety of different type of consumers that are being used and where they're using it.
Okay, those are great points. Last question, also for you, Victor. What kind of training did you need to do for your analysts to use Anodot?
Yeah. So overall, I think the most important thing before even jumping into using Anodot, I was actually helping fix dashboards prior to that. I think what is very important is having those conversations with your business leaders and also your engineering leaders to figure out what historically has gone wrong in the past. So from a very top-down level, understand what are those key metrics there. And then once that is understood, I think like learning Anodot was very secondary. It was just honestly just teaching the functionalities of Anodot, what alerts were available, why they were important, and then lastly, how we can respond to these alerts more seamlessly. And honestly, like some of these things occur naturally because we just threw a handful of people into a Slack channel and also explained to them like during our stand-ups, like this is what Anodot is, this is how it can be used to augment the dashboards that they were currently monitoring.
Well, thank you, Victor. And thank you also for your presentation. And thanks to Sam and Ira and all of you for joining. And this will conclude our webinar for today, Autonomous Analytics in the Real World. Thank you.